Hi everyone. Remember R, the set of real numbers, which we can represent graphically by the real number line. Now, we can associate this right arrowhead with the idea of infinity. Remember that symbol. Infinity, which is denoted by this lemniscate, is a quantity that is greater than any real number, even 10 billion or 10 trillion. So infinity, bear in mind, is not a real number. It's the idea of something that's bigger than any real number. Likewise, negative infinity is a quantity that's lesser than any real number. And we tend to associate negative infinity with the left arrowhead over here on the real number line. We're going to need infinity and negative infinity as we describe and represent sets or subsets of real numbers. So let's say that we want to represent a subset of real numbers. Well, if we just care about a couple of real numbers, like 1 and pi, we can just separate them with one or more commas and surround them with braces. I know students have a hard time drawing these things, but you'll get used to them. However, we often want to deal with intervals on the real number line. An interval corresponds to a connected or unbroken piece of the real number line. A connected piece of the real number line. A bounded interval, such as this one here, a bounded interval has finite length on the real number line. It's trapped between a couple of real numbers. An unbounded interval has infinite length, and it shoots off to either positive infinity or negative infinity. An open interval excludes its endpoints. A closed interval includes its endpoints. And you can have various combinations. So for example, consider the set of all real numbers x such that x is strictly between 3 and 5. This leads to what we call a bounded open interval. It's bounded because we're only considering real numbers that are trapped between a couple of real numbers, and it's open because this interval does not include its two endpoints, the 3 or the 5. These are referred to as strict inequalities. We exclude the 3 and the 5. If we wanted to include the 3 or the 5, we put bars. But these are strict inequalities. Now, we want the set of all real numbers x that satisfy this compound inequality. In set builder form, which involves these braces here, we want the set of all x in the reals such that, so the vertical bar here or the colon here can represent such that x is strictly between 3 and 5. In graphical form, we want all the real numbers on the real number line that are between 3 and 5. However, because we exclude the endpoints, the 3 and the 5 themselves, we put open hollow endpoints at the 3 and the 5. By the way, this interval doesn't just include the number 4, it includes 3.5, 4.99, and also a very famous real number, pi. It's not just 4. There are infinitely many real numbers in this interval. In interval form, we write this as 3, 5 surrounded by parentheses. We use a parenthesis if we exclude the endpoint. All right. Now what happens if we close this off, if we include the endpoints? Then we have a bounded closed interval. The set of all real numbers x such that x is weakly between the two numbers 3 and 5. So 3 and 5 are fair game in this set. They're elements of this set. In set builder form, this is the actual set. In set builder form, it's the set of all x in the reals such that x is between 3 and 5 inclusive. The set includes 3 and 5 themselves. In graphical form, you can see this barbell where instead of hollow endpoints, we have solid endpoints at 3 and 5. We fill in the dots here. In interval form, we don't have open parentheses, we have closed brackets. The 3 and the 5 are included in this set. So these are 3 different representations of the same set. It includes 4, 3.5, pi, and also 3 and 5 themselves. It's a bound closed interval. This time we include the endpoints at 3 and at 5. Let's look at this whole gallery of intervals. I'm glad I don't have to write this on a chalkboard. Okay, you can have intervals that are bounded and half open and half closed. For example, this interval includes 3 and excludes 5. So we have, in interval form, it looks like that. Here, it's vice versa. You exclude the 3 and include the 5. Here, we have an unbounded interval, open interval, all real numbers greater than 3, shooting off towards infinity. Here, we include the 3. We have a bracket instead of a parenthesis. By the way, you always put a parenthesis next to infinity. Infinity is not a real number. You never include infinity in these intervals. So you always put a parenthesis next to infinity or negative infinity. Over here, where these intervals are shooting off unbounded to the left, here we have all real numbers strictly less than 3, open interval. Here, we close it off at the endpoint. We include the 3. R, the set of all real numbers, can be represented by the entire real number line. It's good to indicate where 0 is and also a non-zero number, but we often get sloppy with that. We color the whole real number line. You should remember that this is the interval form for R, the set of all real numbers. Parenthesis, negative infinity, comma, we want everything in between, infinity. By the way, R and also the empty set are both closed and open at the same time. It's kind of weird. All right. Next up, we're going to talk about operations combining and manipulating intervals of real numbers next time.